Okay, so to pick up where we left off, we were talking a lot about lists, and we talked about how they were structured, right? So they're an ordered sequence of values that goes from left to right. They all have indexes. There's a couple things that we can use that are going to act like a list. So for example, if we had the string Zophie, right? So we have this name equals Zophie. We can treat a string much like a list in that we can slice things out of it. So for example, if we want the 0 index of this string, we could put that into name 0 and we would get back the Z. If we wanted the -2, which would take again 2 from the right, then we would get back that character. If we wanted to slice little pieces out of it, we could do that as well. We can also do checks, for example, if Zoe is actually in that name, and that can come back as true or false. This is a great way for doing quick checks as to whether or not somebody typed something that you were wanting, but it's also a way to check for things that may or may not be showing up inside of your strings that come in there. You could also use a for loop if you wanted to. So if you wanted to print each character going down, you could do something like this where you have for I in name, and then you could print I, which is going to go through each one of these characters and look something like this when it gets printed out. All right. Anybody have any questions on list-like type structures? The idea is that you can use strings and treat them like a list. But that does bring us to mutable and immutable data types. So mutable means that we can add, remove, change, whatever we want to do. And immutable means nothing can be changed. So similar to where we had this string here with name equals Sophia cat, if we try to change the 7 index to the, we cannot do that. So we can only modify actual lists. We cannot change things like strings, right? We can do string type things on it, like we can pull out different indexes, but we can't actually change the data itself. Now we can create a new string, in which case if we have something like name equals Sophia cat, we could say our new string is going to be a slice of the original string. We add the word the in there with string concatenation, and then we also concatenate the rest of the line. We can do something like that where name is now going to be Sophia cat, and this is Sophie the cat. All right. But we cannot directly modify a string itself. Okay. Just like we can with lists, if we say eggs is equal to 1, 2, 3, then if we say eggs is equal to 4, 5, 6, eggs equals 4, 5, 6. In this case, though, we're not technically changing what eggs was equal to. We're actually reassigning the entire code, right? It's a little bit different there. We actually remove this entire variable. We completely reassigned it to a new variable called eggs at this point. It's a little trippy, but it's the same. All right. If you wanted to modify the original list, it would be something like eggs equals 1, 2, 3. We would have to delete the second index, delete the first, delete the 0, then append 4, then append 5, then append 6, and we would get that out. All right. So doing this is actually different than doing this in terms of Python. Yeah. This one is actually deleting the values inside of the list and then adding new values back into the list. Yep. But if you look at the actual ID, which we'll talk about the ID function, if you were to do an ID on this particular list, that number gets just a random number from Python. So it's just a reference number. We'll talk about references. If we do eggs equals 1, 2, 3, and then we do eggs equals 4, 5, 6, this will have an entirely different reference number. That's how you can tell that it's different. So this kind of illustrates what you see here is we take each one of those out and we put it right back into the other value there. This one is actually going to chunk the individual values out, then add new values back into that exact same list. Okay. So we talked about lists. We have tuples, and I kind of mentioned that a little bit on Monday. Tuples are identical to lists, except they use parentheses instead of brackets. So lists will use square brackets. These will use parentheses, and they are immutable, meaning that we cannot change their values. We cannot add to it. We cannot modify it. We can't remove it. It's just a set of values. So a good place to use these inside your programs is if you have a bunch of settings for whatever reason, like say you are building a password program and you set settings going across saying that the number 7 indicates the total number of characters that it has to have. And the next one over gives A through Z as a string so that we know that it's going to use A through Z. That kind of thing. Anything that's going to be fixed inside your program would be set with a tuple. All right. You could use a list, but a tuple means that that could never be changed. The code would never have a way of changing that. Another reason to do that, again, for like settings, is that tuples, because they cannot be modified, they are actually faster than lists, right? So if you have a really long tuple, it will actually operate faster than a list. Right. Let's see here. So much like we have converted different types before, you can use the list function and you can use the tuple function to convert back and forth, right? So if I have this list of cat, dog, 5, I pass it into the tuple function, I will then get out a tuple of those particular values. Same way, if I have a tuple here, I can pass that into the list function, then I will get out a list coming out of there. It's also handy if you want to be able to modify characters out of a string, that you end up passing a string into the list function. You can then convert it over to a list, which means you can then modify and do different things if you wanted to. All right. Know how this works. This will show up again. I think it's on the midterm. So understand that if I have a given list, for example, if I say, hey, here's my list, how could I convert that to a tuple, right? I would have to tell you this entire string, not just the tuple function. I would have to say tuple, then the list that I was given inside the brackets. But other than that, it's pretty simple to pass and bounce those around. Anybody have any questions on converting them back and forth? Okay. So references, we've talked about this one a little bit, in that say spam is equal to 42, we say cheese is equal to spam, and then we modify spam equal to 100. Spam is still going to be worth 100 now, and cheese is going to be equal to 42, meaning that we actually took the value that spam was at the case that we declared cheese, and that's what it is at that point on. If we modify spam, cheese will not adjust itself. All right. So they're just storing that variable going back through there at that point in time. Lists, however, don't function that way. So if you have a list here like spam equals 0, 1, 2, 3, 4, 5, we say cheese is equal to spam. If I modify cheese at the one index and say that's hello, then if I look at spam, it's going to be hello. If I look at cheese, it's going to be hello. All right. So assignment operators, when you do this up here, this is pretty normal. However, when you're dealing with lists, the moment you make a change in one with a reference, it's immediately going to copy it over to the other one. So to get away from that, we have to use what's called the copy function. Let me get over this ID here. And you can pass in references. We've talked about that kind of stuff. That's not a problem. So copy. So if you import the copy module, that will allow you to actually copy that particular list and make a true copy of it, so that if you modify spam like this, you can notice that cheese does not carry over into the original spam. Right. So there's copy module, and you want to use the copy function. So you would say copy.copy. If you have a list with lists inside of it, you would use the deep copy function. All right. That's going to allow you to modify that so that it will actually copy all the lists inside and make sure they don't manipulate themselves as well. Anybody have any questions over that? Not too often do you guys end up using this in this particular class. But in long term, if you're coding in Python, there's a chance that you would use copy and copy functions. All right. Outside of that, they're going to show you some examples on how to utilize lists. I encourage you to go down through this one here. We kind of actually did this on Monday, but see if you can accomplish this practice project. That's going to help you adjust and pass things into a list, etc. All right. Again, we kind of did this on Monday. If you go back and watch that video, you can find a similar solution. There's this other one down here where you have coin flip streaks. That's another one that it would be handy to go through and kind of test yourself with and make sure you understand lists. Lists are probably going to be the most common storage type you're going to use. Now, with that being said, we're going to talk about dictionaries next week. Dictionaries to me are more beneficial. So right now, if you're using a list and we have index 1, we don't really know what index 1 is, right? We have to memorize what index 0 is, index 1, etc. So that we have to remember that index 0 is our age, index 1 is our height, index 3 is our name, something like that. Dictionaries, we can actually give it strings for the key as opposed to a 0, 1, 2, 3 kind of thing. So we'll talk about that a little bit more next week, which makes dictionaries very similar to what you would use like a database. So if you start putting things in a dictionary, it's easier for you to convert it to a database later on, if that's what you're going to do. So does anybody have any questions over lists? Clear back to the top. List is a pretty long section. If you aren't quite getting it, go back through the videos of last year or the last time that's in there. Students usually find that handy to go back through the old ones. All right, I'm going to pause the recording or end the recording.